When talking about gases, it's important to understand pressure. So we have all sorts of different units of pressure: atmospheres, millimeters of mercury, torr, inches of mercury, psi, Pascal, kilopascals. These all relate to really different areas of science. Different places use different units of pressure. To point out, these are exact. So if you notice here, I've put them with 3 lines equaling each other. So they're exact. They're not going to affect significant figures when you do atmospheres to millimeters of mercury or torr. Now, if I do atmospheres to kilopascals, that's going to affect significant figures, or psi, or things like that. But if I'm doing atmospheres to torr or millimeters of mercury, that doesn't affect significant figures. And millimeters of mercury and torr are exactly the same. 1 atmosphere is equal to 760 of either of them. When we talk about atmospheric pressure, okay, we're talking about, the pressure of all the air molecules around us. When we look at pressure, we're looking at force per unit area. And so when we're looking at atmospheric pressure, what's the force? Well, the force is gravity, which is why atmospheric pressure is greater at sea level than it is up in the mountains. Up in the mountains, the force of gravity is less, and so you have less atmospheric pressure. You also have thinner air. Okay, so we can do some conversions. All right, I can do this. Atmospheric pressure at the summit of Denali is 606 millimeters of mercury on a certain day. What's the pressure in atmospheres? So I can do 606 millimeters of mercury, 1 atmosphere in 760, and that's going to give me 0.797 atmospheres. That makes sense. 606 is less than 760, so we would expect it to be less than 1 atmosphere. To measure pressure, we can use a barometer, which is how we get our atmospheric pressure, and then a manometer. We put something in a closed system and we can get gas pressure of some sort of experiment or whatever we're doing. Okay. So if I look at a barometer, early barometers were nothing more than a dish of mercury where the atmospheric pressure pressed down on that dish, displaced the liquid mercury, and if there was a tube there, it went up the tube, and so however many millimeters the mercury went up the tube, that was what the pressure was. Okay, so why do we use mercury in barometers? Think about that for a second. Well, there's a couple of reasons. One is mercury does not evaporate readily like water does. And the other is that mercury is 13.6 times more dense than water is. If we were to use water, we would need a column of about 34 feet tall in order to get the atmospheric pressure. That would not work out so well. That'd be really high. You'd have to get on a ladder. It wouldn't fit in most buildings. So mercury was the standard that was used in barometers. Okay. It's important that barometers were vacuum sealed. If a drop of liquid got inside of a barometer and the atmospheric pressure is pressing down and shoving the mercury up the column, but then there's a drop of liquid in there and that liquid vaporizes, now that vapor is going to do a pressure and it's going to push down on that mercury column. And the difference between the column before the vapor pressure and the column after the vapor pressure is the pressure of the vapor. So it's this concept, though, that led to manometers. Okay, so manometers will let you record the pressure of a vapor inside of a system. You can do a closed system, and then just the difference in the height of those is going to give you the pressure. If you have an open-ended manometer, then you have to look at which side is higher, one versus the other, and then you have to deal with the atmospheric pressure as well. Okay. All right, so we can do some pressure conversions. All right, so we've done some heating, we collected some carbon dioxide, we've come to room temperature. All right, so we have a pressure of 291.4 millimeters of mercury. So let's convert that to torr, atmospheres, and kilopascals. Well, millimeters of mercury and torr are exactly the same. So 291.4 millimeters of mercury. I have 760 torr for every 760 millimeters of mercury. So I'm going to get 291.4 torr. That one's easy. Don't need a calculator for that. All right, if I want to go to atmospheres, 291.4 millimeters of mercury. I have 1 atmosphere for every 760. All right, and I get 0.3834 atmospheres. Okay? And then if I want to go to kilopascals, I can look back at the slide that I had a few slides ago, and I will see that there's a relationship there where every 101.325 kilopascals is equal to 760 millimeters of mercury. So I'll do my 291.4 millimeters of mercury, and I'm going to get my 101.325. I cannot write. Kilopascals for every 760 millimeters of mercury, and we're going to get 38.85 kilopascals. Okay, so when working with gases, it's really important to be able to work with units of pressure.